We're going to have a look at this first cubic, which is x cubed plus 5x squared plus 2x minus 8. So the very first thing that we want to do is we want to determine a factor of this expression. Okay, now when we determine a factor, what we want to do is we want to substitute just random values. I'll give you some hints of what values to choose now. For x to make the expression equal 0. Right, so all you're going to do is quite literally just take your calculator. It's a bit of trial and error, and you just are going to substitute in values for x until you get one that gives you a 0. Now, my advice, obviously there's going to be 3 factors for your cubic because it's a cubic expression. So you could potentially get 3 different values as a factor, but my advice is start at 1. So start by substituting in x equals 1. I'll show you what I mean now in a second. If 1 doesn't work, move on to -1. If -1 doesn't work, move to 2. 2 doesn't work, -2. And so you keep going. You should find a factor with somewhere in between -3 and 3. Sometimes it's very rare that we're that mean. Sometimes it requires more, or it might be like a fraction of like a half or something. But generally speaking, between -3 and 3, you should find a factor. Okay, so that's what we're going to do first. So what this is going to require us to do is it's going to require us to substitute in a value for x in our original expression. Now, I'm going to start with 1, but you can start anywhere. But like I say, my advice is start with 1. So I'm going to determine the value of g of 1. Remember, that just means that of my expression g, I'm going to substitute 1 in place of x. So this would be 1 cubed, okay, whatever. No, let's fix that. You would obviously do this on a calculator. You do not show this like I'm doing here. I'm just showing you so that you know. 1 cubed plus 5 times 1 squared plus 2 times 1 minus 8. Right, so doing it on your calculator is going to give you the answer automatically. 1 cubed is 1 plus 5 times 1 squared, so plus 5. Plus 2, so 1 plus 5 is 6, plus 2 is 8. 8 minus 8 is 0. So what this has told me is that x equals 1 is a factor of g of x. Or rather, actually, a solution of g of x, my words. Okay, we're getting there very slowly. Is a solution for g of x equals 0. Okay. This now tells us what our factor is. So our factor that we are going to use is going to be, now you need to imagine what the bracket would be before you solve. So if you think back to like a quadratic, let's say, for example, you had factorized your expression, you got x minus 1, x plus 2, I don't know, equals 0. When you now solved for x, you would have said x equals positive 1 or x equals negative 2. So we now want to go back to the factor, the bracket, that would result in me getting a result of positive 1. And so what we just need to remember is that if our solution to g of x equals 0 is positive 1, that means our factor bracket must be x minus 1. Because when you then go and solve, you bring it over the equal sign, you will get positive 1. So our factor that we're going to start off with is x minus 1. Right, so once we've got our factor, we want to now determine the remainder. Now the remainder will be a quadratic expression. So this is why I say it's the factor and remainder theorem. like I say, this remainder is a quadratic expression. Okay, so we know the first factor. That is what we have found. There's a reason for them, and we go and do it. Okay, so before I carry on, there's a query of I'm lost by the -1. Right, so what we have determined, grade 12s, is we have determined, if we have a look here, that if we were to go and substitute in the value x equals 1 into our equation or into our expression, we will get a value of 0. So what that means is that we have got a solution for g of x equals 0. So that's what we want to do. Now, the reason we want to work with g of x equals 0, like I said, we're leading up to graphs, is remember when y is equal, when y is equal to 0, we are able to determine our x-intercept. So this is going to eventually allow us to find the x-intercepts of our cubic graph. So by substituting in a random value, you would pick a value that you want to start with. Again, my advice is start at 1 and then go up or then go down. You are going to find the value that yields or gives you a value of 0 for your expression. So that's what we did. We subbed it in and we found that 1 cubed plus 5 times 1 squared plus 2 times 1 minus 8 gave us 0. And so what that means is our solution, or one of the solutions to this equation, is x equals 1. Now, what we need to remember is that we now need to go back to what the factor would be. All right. And the factor would be x minus 1. Now, the reason it is x minus 1, if we just pop on over to the side here, is if you think back to a quadratic equation. You got your quadratic equation, you factorized it, and let's say you got these two factors. X minus 1, x plus 2 equals 0. We know from solving quadratic equations, we would have to say x minus 1 equals 0 or x plus 2 is equal to 0. And so that gives me a solution of x equals positive 1 or x equals negative 2. So that x positive 1, that solution that we got that made our expression or equation equal to 0, sort of if we go the step before we got the actual solution x equals 1, has a factor bracket of x minus 1. The bracket x minus 1, when I then make that equal to 0, gives me the solution of positive 1. So when we determine the factor, the bracket, we always want to use the opposite sign. If I had found, let's say, for example, that my solution was x equals 2, my factor bracket would be x minus 2. If it had been x equals negative 2, then my factor bracket would be x plus 2. So we're taking it just one step back before we got the actual solution for x, and we're figuring out where did it come from. So what factor did we have in order to get the solution of x equals 1? Right, does that make more sense, Kani? Just let me know. Okay, cool. Guys, and again, please ask questions because I'm fully aware of the fact that this is brand new for some of you, unless you've already done calculus. But I know it's brand new. And like I said, we've never actually done this before. So this is not only brand new, it's brand new in matric. So please ask. Okay, so we know we've got one factor. Like I say, our next step is to determine the remainder, which is a quadratic. So x squared or ax squared plus bx plus c. Okay, now to do that, we need to work with the original cubic expression as well as the factor we've just determined. So I'm going to try and do this as best I can. There's probably going to be quite a few colors going on because that's the way my brain works, but hopefully it'll all come together. So the first thing that we want to do, which is generally the easiest place to start, is to say, okay, in my original cubic, I have an x cubed. Okay, it's going to fight me, so that's cool. I have x cubed. When I now take into account the factor that I've just found and the fact that I need to get a quadratic, I'm going to ask myself, what do I multiply x by in order to end up with x cubed? Because remember, if you were to distribute all of your brackets, you must end up back at your cubic. So the question we ask ourselves is, x times what gives me x cubed? Okay, so x times what gives me x cubed? And we know that it should be x times x squared, because x times x squared gives me x cubed. So the first position in my bracket is going to be x squared, because if I distribute it all out, I need to get back to that x cubed. Right, the second thing I now look at is the constant term. You don't have to do it in this order, but it's going to be the easiest way for you to do it. So now I go to my constant term. My constant term of my original cubic was trying to be circled, but failed miserably. So let's try that again. Was -8. Right? So again, we go back to the factor we have, and we ask ourselves, cool, I know I have to get a -8. So -1 times what will give me -8? So I'm going on the side here. -1 times what gives me -8? And we know that -1 times +8 gives me -8. So my constant of my quadratic must be +8. Now, this is where you can decide. All right, I know that many of you watch like YouTube videos on maths. I get it. It's a very efficient way to learn for some of us. And the explanation for this part will differ. I use one way. I'll explain both ways just so that you can see, but my brain works on the way I'm about to show you. Remember, for a quadratic expression, you've got ax squared plus bx plus c. We've got the ax squared term and we've got the c term. We now need that middle term, the middle bx term. So the way we do that, and like I said, I'll show you two ways to do it. You decide how you want to deal with this. This is the way I do it personally. I now go and have a look again at my original cubic and I see, okay, I have to get a 5x squared. Cool. Go back to what I have. If I multiply -1 times x squared, I get -x squared. I now need to figure out what my second product here needs to be so that when I add these two products that I get, just shove that down a bit, I'm going to end up with positive 5x squared. So I currently have a -x squared. Let's write it out. So I've got -x squared plus what will give me 5x squared. We know that they need to be 6x squared. I don't know why I'm writing 6x here. Sorry. Would give me 5x squared. So -x squared plus 6x squared gives me 5x squared. So what that means is that I now need to create a product. So let me just take this other circle off because it's in my way now. I now need to create a product when I multiply x with whatever my middle term is of -6x and positive 6x squared. So x, so if we go here, x times what gives me 6x squared? Well, that would be x times 6x to give me the product that I want. And so what that means is that my middle term has to be 6x. Right, I'm going to go through this step again because this is the step I think is probably the most confusing here. Right, I'm grabbing a highlighter, so hopefully we can follow along. I've got my x squared and I've got my constant. I now look at my x squared term, so I've got 5x squared, and I say, okay, if I go down to what I have, if I take -1 times x squared, I will get -x squared. I need to get, however, positive 5x squared. So that's what I'm saying over here. So I'm saying, okay, well, -x squared plus what? So plus what value will give me positive 5x squared? That value that I need to add to the -x squared is a 6x squared, which means that when I now go and distribute x to whatever this middle term is going to be, I must get 6x squared, because -x squared plus 6x squared will give me my 5x squared that I want from my original trinomial. So now I need to ask myself, okay, x times what gives me 6x squared? And that would then be x times 6x. So that gives me my middle term of my quadratic. Right, again, I am fully aware of the fact that this is new. This is, quite frankly, for the first time, probably quite confusing. It comes with practice. Right, so I work with the x squareds. You can work with the x's if you want and use exactly the same logic. I just find the x's confusing. I can't tell you why I find the x's confusing because it's exactly the same thing. My brain just doesn't compute the x's. Would anyone like me to show the x's? Or how you would do it using the x terms rather than the x squared terms? Right, I'm going to assume from the silence we're fine. Like I say, great tools, you can use the x terms. What I'll do in the next question, I'll use the x terms so that you can see, because this is getting a bit crowded. But you can use the x terms, right? There's nothing wrong with it. Like I say, I can't tell you why, but my brain doesn't compute the x terms. Could not tell you why. I just find the x squared terms easier. But you can do it with both. You will get the same answer. Okay, so I'm going to ask again, does anyone have any questions about this finding the quadratic expression that we've just got? Do we all understand how we got x squared plus 6x plus 8? Just give me a thumbs up or a thumbs down. Thank you, Leila. Awami, thank you. Okay, so everyone else, I'm kind of going to assume that we're okay. You need to tell me if you're not okay with something that I'm doing, all right? Okay, so guys, now that we found, thanks Morgan. So now that we found our quadratic, the third and final step is to now factorize our quadratic, if we want to do that. Okay, factorize quadratic. So what we now do is obviously we've got our first bracket, that's not an issue, x minus 1, but now we factorize this trinomial. So we've got x squared plus 6x plus 8. How you choose to factorize this is up to you. We spoke about this a little while ago, I think. You can use the quadratic formula because that always works. If you can just factorize this, awesome. I'm going to just factorize it because I know, again, that's the first thing my brain goes to. X plus 4, x plus 2. And so we have our factorized product. Now, remember, I said right at the start, what I said right at the start, what I said at the beginning of this example is that if we are assuming y is equal to 0, we're able to get the x-intercept. And so what this does is if I now go and make this an equation and say, okay, all of this equal to 0, I know that my x-intercepts are at 1, -4, and -2. And as we go along, I'm going to show you what the graphs will eventually look like that we're going to work with. But if you now are working with cubic equations, what you are able to do by making it equal to 0, i.e. getting it into standard form, is finding your x-intercepts of your graph. Okay, so 3 steps, which doesn't seem like a lot, but 3 steps in order for us to factorize a cubic. Right, so let's take a screenshot of this one, and then we'll have a look at another one together. Again, please ask if you're not sure. Okay. So if we have a look at the second example, sorry, let's do Toriso, is it okay to use? Yeah, like I said, there's a few different ways that you can factorize cubic polynomials. You use what works for you. If that is your preferred method, absolutely. Okay, as long as you're getting the same brackets, it's all pretty much muchness. So if that's what you're more comfortable with, absolutely. Okay. All right, guys. Oopsie. So if we look at example 2, we've got x cubed minus 4x squared plus x plus 6. So again, we just want to factorize this. What we want to do here is, again, we want to first find our factor. So you're going to pick a value for x. It doesn't matter what you pick. Again, my advice is choose something, start at 1 or -1 and go up. And you want to find where this expression is equal to 0. Now, obviously, I've done these. So I know that if we okay, whatever, we're in purple now apparently, and I can't be bothered to change it. If I substitute in -1, I'm going to get 0. You might have started with +1. You wouldn't have then gotten a solution of 0, and so you would have then moved on to the next option. But if you substitute in -1, you get that your expression has a value of 0. And so what you've now found is that one of your factors is x plus 1. Remember, even though it's x, let's try that again. Even though the solution is x equals 1, your factor is x plus 1. You need to change the sign so that if you were to go and solve that equation, you would get the correct x value that you just determined makes this expression equal to 0. Right, so now that we know that, we can say, cool, my first factor is going to be x plus 1. And now we determine our quadratic expression. So in my original cubic, this is probably the easier part, especially when your cubed term has a coefficient of 1. We've got x cubed. We need to ask ourselves, x times what gives me x cubed? X squared. Guys, because you're going to get a quadratic, your first term is always going to be a squared term. If there's a coefficient to that x cubed, so like 2x cubed, then you would times by 2x squared, or you would take into account your coefficient. But that first term should always be squared because you're getting a quadratic. Right, then we're going to go and have a look at our constant term. So looking at our constant term, the original cubic has a constant of 6. And we now need to ask ourselves, 1 times what gives me 6? Well, 1 times +6 gives me 6. Now I move to the middle term. So I'm going to use x's this time just to show you that it does work with both. Again, you do you. Find what you're most comfortable with. For me, this is not what I'm comfortable with just because my brain doesn't work that way. And like Toriso said on the chat, there are other ways to do it. You use what is most comfortable for you. All right. So if we go and have a look at the x term, my original cubic has an x term of +1x. So now this is where I think my brain just starts. We now need to go and have a look at x times the constant 6 because x times 6 gives me an x term. So if I multiply those two together, I get 6x. Now I want x. So 6x plus what will give me +x. Now just be careful. Think about your signs. It would have to be 6x minus 5x to give me a +1x. And so now that is the other product that I need to get. So now I need to bear in mind that when I say 1, stupid thing, 1 times whatever my middle term is, I must get negative 5x, because negative 5x plus 6x will give me the x term. So that means 1 times negative 5x will be my middle term, and that will then take me to my cubic. Again, you are more than welcome to use the x squared terms. That's the one I'm going to use from now on because this in my brain just takes too much brain power. But you're welcome to. You're going to get exactly the same middle term. Exactly the same. And now that we've got all of that, we can factorize our quadratic. So we get x plus 1 and then x minus 2 and x minus 3. Again, if you're not super comfortable with quadratics, just use the quadratic formula. All you then need to do is show the substitution into the formula, and then you just take it back to your factors. So if you use your formula, you need to show your substitution. So minus 5 plus minus blah, blah, blah. And then you'll get your two solutions of x is equal to 2 or x is equal to 3. Just remember to take it back into the factor form, so into the bracket, exactly what we were doing earlier. If it's x equals positive 2, the bracket should be x minus 2. X equals positive 3, the bracket should be x minus 3. So whatever you're comfortable with. Again, I like to just factorize. I don't know why, because it makes no sense when the quadratic formula is there and gives you the correct answer every time. But clearly I'm a bit odd. Right. So let's take a screenshot of the second example. And then I'm going to skip this third example because it's just a substitution. We want to practice. And once again, grade 12s, if you have another way or if you do it slightly differently, it's fine. It's absolutely fine. Okay, this for me is just the one I found easiest and that I have found makes the most sense to students, but also just because I found that doesn't mean it's true for everyone. Okay. Right, so I want you to try factorizing this cubic expression over here. X cubed plus 4x squared minus 3x minus 18. Sorry, don't know what I'm doing. Right, so let's try this one. Use whatever method you're comfortable with. I don't mind. I'm going to give you 5 minutes. I think that should be enough time. And then we'll have a look at the answer. And then all we're going to do is just convert this now or move it now into an equation. That's it. But let's have a look at this. 5 minutes. Please ask me questions in these 5 minutes. If you're struggling, you can unmute yourself. You can put it in the chat. You can raise your hand, whatever you want to do, but please ask. Okay, guys, just give me a thumbs up when you are done. It has been 5 minutes, but if you need another minute, then that's okay. Just give me a thumbs up or thumbs down. Okay, it seems like most of us are done. Awesome. I'm going to sound like such an old person now, but whoever does these like little explodey thumbs up, it's lovely. Love it. Okay. Anywho, right, let's have a look. So again, remember, if you're using a different method, you are by all means welcome to do that. So first things first is I found that x equals 2 is a solution to this expression when equal to 0. So that means my factor is x minus 2. I then found my quadratic, which I factorized, done. Because these brackets are the same, you're more than welcome to write it as the bracket squared. But if you don't, that's also absolutely fine. Okay, it's much of a muchness. You do you. All right. But that's it, guys. So all we're going to have a look at now is understanding what it means when we solve a solution. And what I'm going to do is I'm sort of going to introduce graphs because this is where we're leading up to. I don't expect you to draw these graphs at this point. We're going to learn about how to sketch graphs, but just so that you understand where we're going. All right. So I'm kind of putting you on the spot here, and you are welcome to say no. Right? And mostly just because I know for myself, I'm not super comfortable with synthetic division. Would you like to explain how you did it with synthetic division? You are more than welcome to say no if you don't want to. But, you know, another alternative method for people. Like I say, you can say no. No pressure.
Ma'am, I'm not completely sure how to explain.
Okay, no, that's cool. Don't stress. Okay, so guys, what I will do, and again, it's probably also for myself, just to like gain confidence in something new, is what I'll do is I'll put a little explanation on the Google Classroom of how you do it, just because it's always good to have another way to do something, particularly or especially if you're not comfortable with the way you currently have. So what I'll do is I myself will make myself better at synthetic division because, like I said, it's not something that I am particularly good at either, just because it's not the method that I choose to use. But I will put something up on Google Classroom so that if you want an alternative method, you've got one. Alrighty. Okay, so if we now head into the equation arena of life and cubic polynomials, remember I said right at the start, we have a general formula of our polynomials of ax cubed plus bx squared plus cx plus d equals 0. This is what we call our standard form. This is not new. Quadratics is pretty much the same. Quadratics ax squared plus bx plus c equals 0. But we always want our equation in standard form before we start solving the equation. Now, what you need to bear in mind is because of the degree of this expression, so because it's to the power of 3, you will always have at most 3 real solutions. All right, sometimes you get non-real solutions. It's very rare for cubics, especially if you're going to graph it, but sometimes, as we've now seen in this example, you get solutions that are the same, the two brackets x minus 3, but you get 3 solutions. All right. And maybe I should even put in here to be better, at most 3 different real solutions. Some of them will be the same. Okay. And those will lead us to our x-intercepts for our graphs. So let's have a look at this first one here. You can ignore the graph right now because that's not important at this moment in time. We've got 2x cubed plus 5x squared equals 3x. So first things first, we need to put it in standard form. Okay. Can't do anything if it's not in standard form. So 2x cubed plus 5x squared minus 3x equals 0. And now the first thing I need you guys to notice is that we don't have a D term or no constant term. And that is going to need to feature in our thought process as we now factorize this, what is this thing called? Cubic equation. Alrighty, so first things first, we follow our steps, same as always. Find a factor. Again, you just sub in and you're going to find a factor. And we get a factor that x will be equal to -3. So this was a bit of a nasty one because you have to do quite a few steps. But you get that if you substitute a -3 into your equation, you get it equal to 0. So our first factor that we get is x plus 3. And now we have to find our quadratic. Now, we need to be careful here because we don't have a constant term. So I'll get to that in a second. If we now look at the square term, this is actually what I said earlier to you. Because you've got 2x cubed in your original cubic, you now need to ask yourself x times what gives you 2x cubed. And so that would be 2x squared. 2x squared times x, 2x cubed. So you just account for your coefficient if there is one to your x cubed. It's not something we need to panic about. Okay, so we've got that. Now, usually we would go to the constant term, but what we need to be careful of is we don't want to have 3 times, let's say, for example, I made this up, -1, because 3 times -1 is -3. There is no constant in my cubic. I can't have a constant. And so what that means is that we're not actually going to have a constant term in our quadratic. So now we move on to our next step. We say, cool, can't use a constant, that's okay. Let's move on to the squares. So 3 times 2x squared is not 3x squared, it is 6x squared. So try math again. 6x squared, but I want 5x squared. So that means that when I say x times whatever this next term is going to be, I need to get a negative x squared because 6x squared minus x squared will give me 5x squared. So that means x times, it's going to be a poop now, times minus x will give me my negative x squared that I want. Okay, I'm just going to run through that little bit again. We know we want to get 5x squared. I know that when I say 3 times 2x squared, I get 6x squared. So that means that when I say x times whatever the second term is, I must get minus x squared because 6x squared minus x squared gives me the plus 5x squared that I want. And so that means x times negative x will give me negative x squared. So now I've got my quadratic. It's not in the usual form that we're used to, but it is still a quadratic. And now we factorize. Okay, so when we go and factorize, because there isn't a constant term, we're not going to factorize it like a normal quadratic. But if you have a look at your bracket, you've got 2x squared minus x. You've got a highest common factor. So we'll take out our highest common factor of x. Now you still have that bracket x plus 3. And remaining, once you've taken out your highest common factor, is 2x minus 1. Now, guys, remember, when you have a highest common factor, you put it right at the start. Some of you might feel more comfortable to write this initially as something like this and then move your x to the front. That's absolutely fine. As long as you take out the highest common factor, you're okay. Now that we've done that, we can go that step further and actually solve for x. So first factor, x equals 0. That's done. Don't really need to do more. Or we now take our second factor, x plus 3 equals 0. So our solution would be x equals minus 3. And then our last solution, 2x minus 1 equals 0. And so x is equal to a half. So we get our 3 solutions for where that equation was equal to 0. And so if you now have a look at my graph over here, I've plotted, so there's programs that you can use. I went and plotted 2x cubed plus 5x squared minus 3x, and this is the cubic function that I got. We're going to learn how to draw these, so this is what you have to look forward to in the next few lessons. But you can see there is my first, or there's one of my x-intercepts at -3. Here's my other x-intercept at 0. And here's my final x-intercept at 1/2. Okay, it tells you exactly where your x-intercepts are. So all we're doing is we're factorizing. That's it. But now we are actually going that little step further and actually finding our x-intercepts so that we can eventually plot a graph. So on Monday, when we do graphs, we're going to have to go and find x-intercepts. Because remember, whenever you sketch a graph, you have to show all intercepts with the axes. And in this case, we'll also need to show the turning points, which we'll chat about on Monday. All right, but same as what we've been doing. The only difference with this one was the fact that we had a 2x cubed, but like I say, you deal with it like normal. You ask yourself the same question, you just now have to take into account the coefficient. And because there wasn't a constant term, we're not going to have a constant term for our quadratic. Okay. Let's take a screenshot here. If you've got any questions, though, let me know. Otherwise, I think we've got time for one more. I back us. Okay, let's have a look at example 5. So we've got x cubed minus 12x equals -16. Oh gosh. And once again, we are trying to solve for x, so we're trying to solve our equation. First things first, though, I have to put it in standard form. If it's not in standard form, it is completely useless. So standard form here would be x cubed. I don't know what that is, but anywho, x cubed minus 12x plus 16 equals 0. So again, just be mindful of what terms you do and don't have. I now don't have an x squared term, but that's fine. Okay, as I've already explained to you earlier, you can use the x squared terms to get your quadratic, but you can also use your x terms to get your quadratic. So I'm not stressed, we're good. So step 1 is we want to find a solution, a root for this expression. So we sub in values for x until we get the expression equal to 0. In this case, one of your solutions will be x is equal to 2. So that means my bracket will be x minus 2. So that's the first one I can write down. Now I go and get my quadratic. So I need an x cubed, which means I've got an x squared. X times x squared is x cubed. I need to get positive 16, but I've got a -2. So that means I would need to multiply by a -8 in order to get positive 16, because a negative times a negative is a positive. And now, as much as my brain doesn't like it, I need to work with those x's. So, sorry, see, my brain doesn't like it. Just got a block to it. If I say x times -8, I get -8x. But I want -12x. So what that means is, when I multiply this -2 by whatever this middle term is going to be, I need it to be a -4x. So that I've got -4x minus 8x giving me -12x. So -2 times what will give me -4x? That would need to be multiplied by 2x. So I get my middle term. So even though I don't have the x squared terms, like I said, it took my brain a second to compute just because it's so programmed to do what I'm used to, but you can still find your quadratic. Once we've got our quadratic, we factorize it, giving us x plus 4, x minus 2. Again, guys, use your quadratic equation if you know that you're not super comfortable with factorizing quadratics. I'm doing this with my grade 9s at the moment, so this is, again, in my head. And now we can solve our equation. Now, in this last example, I actually said x plus 3 equals 0, 2x minus 1 equals 0, and I went like that. You don't have to do that. If you can just read your solution immediately or get to your solution immediately, that's fine. So our first solution, x equals 2, or x equals -4. or x equals 2. Okay, now I want you to notice something. So those are 3 solutions. I said right at the start, you will get a maximum of 3 different solutions. In this case, what we have is super exciting because we've got 2 solutions that are the same. Now, that doesn't mean anything super crazy. What it means, though, is if you think of a parabola, so I'm going to take a little tangent here. If you got x minus 2 for your parabola, your one solution would be x equals 2, which means you've got one x-intercept. So your parabola would look something like, not like that, because that's not a parabola. Don't know what that was. Something like this, where it's got one x-intercept at positive 2. All this means when your solutions are the same is that you have an x-intercept that is also a turning point. And so a turning point. And so now if we have a look at this graph, that's exactly what we have here. There's that x-intercept of -4, but here is both an x-intercept and a turning point of 2. Now, again, this is not something that I expect you to just know. We're going to talk about this again on Monday, so don't stress about it. But it is important to start making connections with knowledge you already have. So like I said, you know this. I'm saying this because I also understand the fact that functions happened a long time ago. You know that when you get 2 of the same root, 2 of the same solutions, it means that if you contextualize it in a parabola, your turning point is your x-intercept, or your x-intercept is also your turning point. This is the same thing for a cubic. It just so happens because of the shape of your cubic, you will have an x-intercept that's just a normal everyday x-intercept, but then you also have a special x-intercept that is both x-intercept and turning point. So when you do get 2 of the same solution, it's not the end of the world. It just means something specific for your graph. It means, like I say, an x-intercept that is also a turning point. All right, guys, but let's take a screenshot of this. I know it's 3 minutes early, but I would really appreciate if we were doing our quizzes. So I'm going to say once you've got your screenshots,